On the previous chapter 3.2, n was given, I was given, the present value was given, and then we have to calculate the future value. We didn't have any payment, so payment was equal to 0, and the p/y we just put 1 because this is how many payments you had per year. You had a single amount. So payment was 0 and p/y was 1. Now on chapter 3.3 we're going to have a payment, for example $100, $200 and so on. The present value will be 0 and we have to look for the future value. Because we have a payment, the p/y will be a number. If you make, let's say, payments semi-annually, will be 2. If you make payments quarterly, will be 4. Monthly, which is the most common, will be 12. p/y and c/y will be the same. One more thing that I want you to notice is that n is going to be the number of years times the number of payments. So if you have, let's say, 10 years, and then the payment, you make 12 payments per month, 10 times 12 will be 120. If you have 5 years, and then the payments will be quarterly, 4 times per year, 5 times 4 will be equal to 20. So let's go to start with annuities and sinking funds. An annuity is any sequence of equal periodic payments. An ordinary annuity is one in which payments are made at the end of each time interval, and that could be the month, could be a quarter, and so on. This is the formula for a future value of an annuity. FV is the future value, PMT is the payment, and then parenthesis 1 plus I is the interest, N is the number of periods. And one more time, if it's quarterly and it's 5 years, you multiply 4 times 5, 20. And then the I in the denominator will be also the interest rate. Now, you don't have to use the formula because we will see how to use the graphing calculator. So, let's go to see this example. In this case, what we have to do is that we have to follow the same steps. So we have to figure out first of all what is the n. As you can see, the n is 15 because it's 15 years. However, you have to multiply by 4 because the payments are every quarter. So you can multiply 15 times 4 and this is going to be equal to 60. The interest rate is 6.5. We don't have a present value from now on, so present value will be 0, but we have a payment. The payment is going to be $1,000. Then the payments are made at the end of each quarter, so you have 4 payments per year compounded quarterly. P/y, C/y will be equal to 4. And then you calculate the future value, alpha, enter. So this is going to be the future value. That means if you make every quarter for 15 years $1,000, after 15 years the future value will be $100,336.68. And this is the answer by using the formula. Now, the interest that you are going to earn will be the future value minus the amount that you gave all these 15 years. So its payment was $1,000. So over 15 years you made a total of $60,000. As a result, the interest will be the future value that we just calculated, 100,336.68 minus the 60,000. So the interest that you are going to earn is 40,336.68. Now, any account that is established for accumulating funds to meet future obligations is known as a sinking fund. The sinking fund payment is defined to be the amount that has to be deposited into an account in order to have a given future value. So, before we know the payment and we try to calculate the future value. Now we know the future value and then we have to figure out the payment. So in this case, for the formula, we have to solve the previous formula for a payment. As a result, the payment will be the future value times the interest rate over 1 plus I, the interest rate raised to the power of n minus 1. But again, we may use the graphing calculator. The difference is that now the unknown is going to be the payment. So let's go to see this problem. So how much Harry has to save every month in order to buy a new car that is going to cost $12,000 in 3 years? So he has to save every month. As a result, if he has to save every month, that means that the end will be 36. Why? 3 years times 12. Don't forget, for the n, if we have payments, we multiply the number of years times the payment. How many payments you have. The interest rate is 6%. Present value, of course, 0. Now the payment is the unknown, and he wants to have 12,000 after 3 years. P slash y, C slash y will be 12, because the problem says clearly save each month, and as we mentioned before, the two quantities will be the same. So the unknown in this case will be the payment. Alpha, enter. So the answer is 305 and 6 cents. That means he has to save $305 and 6 cents every month in order, after 3 years, to accumulate $12,000 in order to buy a car. Now, for this problem, for the interest rates, the unknown is going to be the interest rate. So let's go to see this problem. So he has to deposit $150 every month, and then he's looking for the interest rate after a 14-year period. So it will be 14 years times, he saves $150 per month, or deposits $150 per month, so times 12. The interest rate is the unknown, payment is $150. Now the future value, we have to do the same steps as the previous chapter. That means if the payment and the future value are given, one has to be negative, the other has to be positive. So in this case we have to use the negative sign, negative 85,000. It doesn't matter if the negative is on the payment or in the future value. And then P slash y, C slash y will be equal to 12, because he deposits the $150 per month. So the unknown is going to be the interest rate. Alpha, enter. 15.04. I have here 15.03. Depends on the number of decimals. So 15.04%.